From the latest statistics, Australia has the highest rate of pet ownership in the world. Around two-thirds families own pets. It's estimated that more than 24 billion pets in Australia, as well as around 60% of people who do not have pets but willing to get pets in the future. That stats a huge population in Australia have or will have pets. However, some common scenario of owning pets will be a disaster for people who own the pets first time. This is because they do not have any experience of how to take care of pets. Sometimes, their unpredictable behavior might cause confusion to them. Moreover, people are desire to share their experience with other people.
Hence, pet care is designed as a platform, similar to a forum communicating pets' life. Inspired by the existing website RSPCA, Pets Forum containing some tips to feed pets, enhance the discussions between the pet owners and beneficial to solve related problems. Besides, pet care not only allows users to share their joyful and experience with pets to each other, but also help users looking after their pets following the tips. Except this, the web application will analyze the body index with detailed information from other pets as reference, as well as predict quantity of pet daily food intake through the knowledge of machine learning, supported by Spark ML Lab. Basically, the primary audience we target is the owners who have pets, in particular the people with multiple pets at home. The tips and experience may help beginners solve some common conditions and scenarios without visiting the vets. And then the second target audience is pet care company, such as Healthy Pets Plus. By checking body index for each pet and the pet's information, any potential problems will be exposed to those companies. Then they could lend a hand. Similar to the existing websites, Pet Care allows users to create accounts and log in, log out. The users are allowed to reset their passwords under the condition of forgot password or changing normally. Users have to provide personal details to complete their profile when they register. They can update profile anytime. The main function is editing pets details, uploading pets image, and deleting pets in this web application. They are also able to post tips, share experience, view others' posts, and delete previous posts. Pet Care will also provide statistics of total number of users, pets, as well as the daily logged-in users. Except the following functions, it is able to predict food intake and classify the variety of pets by giving images, SQL queries, graph processing, and machine learning. It provides an efficient abstraction for in-memory cluster computing. Python supports it, and the Spark ML Lab implementation is visualized in both user interface and Jupyter. Machine learning of food intake prediction is at page statistics, whereas the variety classification is on Jupyter Notebook.
As mentioned before, we utilized some web development technologies to build front-end such as HTML, CSS, JavaScript to visualize the result as well as Jupyter Notebook, while Python is used to access, modify, and display data. Implementing backend and supporting Spark. In addition, all data will be stored in Cassandra, which will be processed by Spark. For cloud computing, we firstly set up the cluster environment on virtual machine which hosts on Google Cloud Platform, then developing the web applications through Python. We also used PySpark to support our machine learning. Map and linear regression is used in our project. There are two functions that use machine learning, predicting the cat's daily feeding amount and the user upload image recognition to classify their species. Apache Spark is a fast vertical computing engine designed for large-scale data processing. Spark has the advantage of Hadoop MapReduce. It eliminates the need to read and write the HDFS, so Spark is suitable for data mining and machine learning. In our project, we used traditional machine learning and deep learning packages with Jupyter. We create and edit the code equations in real time, which made the code visual and narrowed in text. In our function, we store the training data in the form of SCV file, and then we use the Spark session to provide a single point of entry to interact with underlying Spark functionality. Spark session reads the SCV file and create a data frame. Set the feature columns from the data frame. Then using PySpark feature package to transfer the feature column to be the feature vector and get a new data frame to support the training. After training, we could get the trained model that can support our function. For our database, Cassandra is used to implement a distributed database to manage the large amount of data. It is essentially a benefit on highly available servers with no single point on failure. Well, we have two cluster nodes for this project. It is used to store our user detail and the pet information.
Here is the user interface of our web application. Without login, you can only see the statistics and about us page. In statistics page, machine learning knowledge is applied on pet daily food intake prediction. You only need to input the age, gender, and weight of your pet. Then the result will be displayed at red box. We are also recording the number of users and pets in this web application, as well as the number of daily users. Now I'm going to show you how to create a new account. Firstly, you select the photo as your avatar and input your personal details. Then click the button Add. The pop-up window shows you have created a new account successfully. After signing up, log in with the username and the corresponding password. And you will see the navigation is different from before with the addition my pets and forum page. In the page of my pets, you will see a detail card of you. It shows you have 0 pets for now. Let's try to add a new pet by clicking the button. Similar to user register, you have to upload an image and input all the pet's details to add a new pet. Once your pet is added successfully, the page will jump back to My Pets, and you will see your pet is displaying behind. If you click the button See Profile, it will jump to the pet's detail page, showing all information. The graph displays not only the weight of your pet, but also the average and maximum weight. If you are willing to modify the details, click button Edit to turn to edit mode. You can either edit details or delete the pet directly. Once the pet details are updated, it automatically jumps to My Pets page again. Well, your personal details are located in Profile. You can find it in drop-down menu and click Edit to do some changes and save it. All the posts are in forum page. There are 2 tabs, My Posts and All Posts. The content of post is hidden unless you click the topic. I'm trying to create a new post. Type in topic and body text. After new posting, it appeared that both My Posts and All Posts. Managing your own posts is that My Posts allows delete action. Back to the statistic page, you can see the number of users, pets, and the number of daily users increased. The last page about us briefly describe our web application and introduce the members of our development team.
Our first function is to predict the pet's daily feeding criteria. After importing the Spark package, we create a Spark session to read the pet CSV file to get the first data frame named data. Then take out the data as a feature using factor assemble function to get the data frame that includes the future vector. The next part is machine training. After importing linear regression package, we would get the model. We can use this trained model to predict the data. In our example, we insert 2 rows into the data frame as a feature vector and input into the trained model. Based on default machine learning, the model will tell us the prediction. Our second function is image recognition. In our design, it's only used to identify the cats and the dogs. The first Python file is deep learning. By using PyTorch and ResNet 18 model to get the feature of the image. The number of features we designed to collect in our project is 2048. For each picture, we convert the collected data into a CS file named chain final as a chain file. The number is around 1000 groups. Then we have done with the first function. We do the machine training and get the model. Then use the trained model to predict the data. For example, we have got the features of Cat7 JPG, converted to CSV file and imported into the trained model. According to the standard we tested, the value is over 0.7, it's probably a cat. Otherwise, it's a dog.